In this video, we will calculate probabilities using permutations. So before we get started with an example, let's review this formula for calculating a probability. In our numerator, we have the number of ways that some event, we're calling it sigma, can occur. So as we're reading a problem, we can think about defining the event sigma, and we want to determine how many ways that event can occur. And then we always divide our probability by the total different number of possible ways or possible outcomes there are. In this case, those will be how many permutations are there, or how many different ways can people or things be arranged. So let's see this as an example. Suppose a radio show is holding a contest where the first, 25th, and 50th person who call in win tickets to a concert. Assume that 50 people decide to call into the show. If Lisa and her friends call into the show, what are the chances that Lisa is the first caller, Renaud is the 25th caller, and Olivia is the 50th caller? So we want to calculate this probability. Before we get started, what is the event that we're interested in? In other words, sigma. Lisa is the first, Renaud is the 25th, and Olivia is the 50th. This is what we're going to call sigma. So we want to first determine how many different ways can that specific event, Lisa being first, Renaud being 25th, and Olivia being 50th, how many times can that happen? So in order to visualize this, I kind of like to draw out the spaces and determine how many options there are. So here is the first caller, here's the second caller, and then since there's 50 of these, right, we're not going to write down all of them, but then there's the 25th, and then there's some more, and then we have the 50th caller. So for this event that we're interested in, we have Lisa, and then we have Renaud, and then we have Olivia. And then the other people in there could be arranged in so many different orders. But what is fixed is our three people. So Lisa, Renaud, and Olivia are fixed values. So those cannot be moved because that's what we're interested in knowing. Okay, so we have all these other places that people can fill in. So we're told that 50 people call into the radio. So how many different options do we have for who can call in second? We have 47. What about who can call in third? We have 46. Down, 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 and you can kind of see the pattern happening. And then how many options do we have for who will call in 49th? We have one option there. So if we multiply all these together, and you can think about our fixed options here for the people that we are interested in, you can kind of think of that as, well, there's only one option for that because that's what's fixed. So if you imagine multiplying 47 times 46 times 45 all the way down to 1, that's the same as 47 factorial. So our probability, our numerator, there are 47 factorial ways for our three friends to be in those three specific places, first, 25th, and 50th. Now our formula says that we divide that by the total number of permutations. So our total possible ways that we can arrange these 50 people into 50 places to call in for a radio show. So that's if we don't specify our friends to be in these specific three spots. That would be 50 factorial ways to arrange all 50 people. So 47 factorial divided by 50 factorial. And you can do some simplification here that leads us to 1 over 50 times 49 times 48. And this is a really big number, So it's 1 divided by a big number, which gives us a very, very, very small decimal. And we'll simplify that very small decimal into 8.5 times 10 to the negative 7 power. That's written in scientific notation, but really it's 0.000000085.